Find the elements of matrix A. So matrix A is multiplying a 3 by 4 matrix, and the result is another 3 by 4 matrix. And so let's figure out first, what are the dimensions of A? For matrix multiplication, you want to make sure that these two numbers are equal. Okay? And the result is going to be these outside numbers. So make sure the number of columns for the first one is equal to the number of rows of the second one. And then the resulting matrix will be the number of rows for the first one and the number of columns of the second one. So for us, let's say that matrix A is an m by n matrix, and then the matrix it's multiplying is 3 by 4. So because these two are equal, we have n is equal to 3. And the resulting matrix is a 3 by 4 matrix. So that makes m equal 3. Okay, so m is equal to 3. So that means A is a 3 by 3 matrix. Okay. That's step 1. Step 2, notice that the first two rows here are exactly the same as the first two rows on the right. So what that means is, do not do anything. Now the question is, what do we multiply by something to get the same result? Okay. Well, if it's simply multiplication, you multiply it by 1. But in terms of matrices, you have to multiply by the identity. Okay, so for the first two rows, multiply it by the identity, because then it doesn't do anything. Okay. Now the identity is once in the diagonal and then zeros elsewhere. So keep in mind this matrix is a 3 by 3 matrix. So I'm only doing the first two rows. So this is behaving like an identity matrix, except the last row is going to be different. And that's what I need to find out. So I'm going to call the last row A, B, and C. Call it any three variables you want. So when I multiply this by the matrix on the right, I should end up with this resulting matrix. Well, the first row is the same, and the second row. But the last row is 0, 1, negative 1, negative 1. Okay. So that's what I need to have it equal to. So I'm only going to be interested in the last row because that's where my variables are. And so what we're going to do is take this row and multiply it by each one of these columns. So if I do the first row, the third row of the first column, we have A, and then B is 0, B times 0 is 0, and then multiply 3 and C. That's going to equal this 0 right here. And then we move on to the next column. So when you move on to the next column, you're going to get 1 here on the right. So we have A times negative 5, B times negative 5, and then C times negative 14. That's going to equal 1. Then we move on to the next column. We'll have A minus 25B plus 2C. That's going to equal the negative 1. At this point, I can stop because I only want 3 equations. And the reason I want 3 equations is because I have 3 unknowns. The unknowns being A, B, and C. So I can stop here. And the way to solve this, there's many ways to solve it, but I would just solve for A here and get that A is negative 3C. And then plug it into these bottom equations. So this will be negative 5 times negative 3C. And then, let's see, negative 5 times negative 3C is 15C. 15C minus 14C is just C. C minus 5B is 1. And then here, the last row, the last equation, will substitute negative 3C. I have negative 3C plus 2C is negative C. And then I have negative 25B is equal to negative 1. Now, I'm going to add these two equations. These are going to cancel. Negative 5b plus negative 25b is negative 30b. 1 plus negative 1 is 0, and so that means b is 0. Okay. B is 0, I can, I guess, plug it into this equation. If b is 0, this goes away, and I have c is 1. Now, if c is 1, I could plug it into this equation. That means a is negative 3. So I can plug it in here now. A is negative 3, B is 0, and C is 1. And so the answer that we're interested in, our matrix A, this is our matrix A. It's going to be identity for the first two rows. And then the last row is negative 3, 0, and 1. And that's our final answer.